All right, thank you very much. I am obviously here to discuss microservices architecture in the real world. And the reason for my putting together this talk was that I've found in discussing microservices architectures with people, we hear the good stories, we hear the success stories, we hear about the companies that have made a successful transition and it's running great and they're really happy about it. And those stories exist, but they encountered strange things on the way, as did we. And so I put together this talk as a way to discuss some of the things that will pay off if you think about them early on when considering a microservices migration. So some quick introductions. I'm a senior staff engineer at Credit Karma, and Credit Karma is here in San Francisco primarily, and our mission is to champion financial progress for everyone. We help our consumers understand their credit scores, understand what harms and helps their credit scores, and steer them in the right directions. So we have about 80 million members around North America who we are helping. And we're currently about 800 employees, about half of that is engineering. And we have a PHP monolith and about 90 microservices running in production today. And about 2.5 years ago, when I started down this path at Credit Karma, we had a PHP monolith and 0 microservices. And we were about half this size, so we were at about 200 engineers. And as you can imagine, 200 engineers all merging into a PHP monolith and trying to release twice a week is not fun. So perhaps you've decided to adopt microservices, or you're thinking about it, or you're just dreaming about it. But either way, congratulations. Maybe. When you set down this path, there are a ton of things to think about, and in order to not make this a 3-day long talk, I focused on 4 main buckets, and it's wonderful that the prior talk talked about security, because that's one that I had to leave out because it's huge. But these are the 4 buckets that I really chose to dive into during this talk. Routing, simply how do requests get from one service to another? Management of microservices. You've got all these containers running in production. What do you do with them? How do you manage it? Observability, understanding what's going on out there when you've got all this stuff running. And then experience, which in this case is user experience, aka your developers. What do microservices mean to your developers? So you're imagining your microservices, and you've got some nice services talking to other services, and it's pretty clean. You can kind of understand it. And in reality, it's more like this times 10. It's very, very quickly going to become more than anyone can hold in their head, more than anyone can really understand without some help. But it doesn't all have to be like this guy. There are ways to prepare for it, and that's what I want to dive into. And I know I'm short on time, so I'm going to jump into it. Routing, traffic control, really. How do requests get from one service to another, from service to a legacy piece of code, from a legacy piece of code into your services world? It seems like a pretty straightforward question, right? You've got service A wants to call service B. Fine, service A sends a request to service B, right? It's not actually quite that easy. There are a lot of questions that service A needs to answer before it can send a request to service B. You know, where are all of these instances of service B running? How does service A find them? How does service A know which ones are healthy, which ones are potentially too busy to take requests? And very importantly, back to the security question, should service A be allowed to call service B in the first place at all? So service discovery is key number 1. Some of you may already be thinking about this, looking at questions like this, or working with some of these tools. The probably best known service discovery tool out there is Consul from HashiCorp. and basically a fancy key value store that has primitives and management for services, and very importantly, health checks for services. So it knows not just where are all of the instances of Service B running, but which ones are actually responding to their health check, which ones are good to send the request to. There are other ways to do this. There are other tools. There's Zookeeper, very similar. etcd kind of does this to some extent in the Kubernetes world. You can also do this with simpler tools. DNS is kind of made for this, except that it doesn't really manage the microservices world all that well. You need to know not only where is a service instance, but what port is that particular instance listening on, and DNS doesn't really do that out of the box. You can also just run services on instances behind a load balancer, but that kind of ties you to one instance of a service per VM if you're running in AWS. It's not really going to scale with you, but it is a way to kind of get things going initially if you want to just kind of play around and explore. Once Service A knows where the instances of Service B are and where the healthy ones are, it still has a decision to make, which is which one of these should it send the request to. How do we load balance this? Do we just round robin? Do we randomize it? Do we try to do something clever like least loaded? It's a big question. Then you send the request, and maybe it times out. How long should Service A wait before deciding that Service B timed out? Should it retry when that timeout happens? And every service that it's calling B, C, D, and E might have different timeouts, might have different retry budgets, and it gets very, very complicated. And at what point should it decide, Service B is just done. The team screwed it up and it's all gone. When do we circuit break it and just stop trying? And this all kind of leads into the question of defensive programming. When we're working in a monolith, we're all sort of accustomed to everything being there. Right? You're writing some code, you're calling some other code, it's going to be there because we're all in this together. It's much simpler in that way. When you start to break this up into a distributed system, you have to assume that at times the services you're trying to call are not going to be there. They're going to be down, they're going to be unhappy, the team screwed up the deployment, something goes wrong. So thinking about how to handle that, what it means to the code that's making the call, and ultimately what it means to the users of your system is what's important. Can you render most of the page, but not a piece of it because the service responsible to it is down? How can you do the best you can with what you've got is really what it comes down to. The management of all of these questions around routing comes generally in two flavors these days. There's the client-side management, where you build the logic into the client to understand how to do all of this, how to find Service B, how to decide which one to send to, how to handle errors, and so forth. Or nowadays, it's becoming more and more common to see the service mesh approach. It's kind of hard to look around the microservices world without reading about service meshes these days, whether it's Istio or Envoy or Linkerd or all of these various tools. And the service mesh essentially extracts the logic for handling all this stuff into a sidecar running alongside your services. There are definite advantages to the service mesh. Number one, you're probably going to want to write services in more than just one language. If you do the client-side management of this, you end up maintaining client libraries in every language that your developers want to use, and distributing them and keeping them up to date and upgrading them and so forth. And it actually gets really, really complicated very quickly. Service Mesh also lets you centralize a lot of things: observability, security management, and so forth. The configuration of those, the policies and administration, all gets centralized into one piece rather than spread across all of the services. And then lastly, meshes can make it much easier to span subsystems. If you've got a couple of clusters of microservices or some legacy systems, they can leverage the service mesh as well. The main disadvantage to service mesh is certainly that it's another component that you're adding to your infrastructure. And more than that, it's an absolutely critical component of your infrastructure. If your team doesn't know your service mesh well, doesn't know how to maintain it, how to manage it, how to watch it, observe it, and so forth, then it can bring down your entire system very, very easily. So it's a critical component to be very good at managing. So when it comes to recommending kind of what to do these days, in general, I would point people to running Consul. It's fairly straightforward to set up, fairly straightforward to start working with. The Envoy mesh backed by Consul for the service discovery can let you get started. If you're looking at the Kubernetes world, you can't move without tripping over mentions of Istio, which about a month and a half ago is finally 1.0 GA. Still very young, but very, very interesting. And really in the Kubernetes world, there's not much reason not to try it. Barreling ahead into management, the placement of all of these containers. Where do they go? How do you decide where to put one, where to run one? How do you find where they're all running? How do you manage them overall? First thing is to ask yourself, are you looking at running lots of services on lots of servers, trying to make best use of your resources, be really efficient with things, manage resiliency, auto-scaling, and all of these great things? If the answer is no, then don't necessarily jump into some complicated tool right off. We at Credit Karma started out running services in our data center by installing Docker on some servers we set aside, playing with them, running some containers, and getting used to what it means to run Docker in production. If we had waited until we investigated all of the management tools out there, picked one, put everything in place, it would have been months before we had anything running at all, and we might have made the wrong decision. But if you do start out yourself, keep a close eye on how things are going. We went from one service to about 4 or 5 services in a couple of months, and then suddenly we were at 10 services and then 20 services, and every team wanted to start running services, and we were trying to get ahead of the demand and figure out how to manage all this stuff that we were suddenly running. We didn't really plan ahead quickly enough, and we underestimated how quickly the maintenance load would grow as we ran more and more services. So you find yourselves, like we were, suddenly running lots of services and wondering what's going on. We were literally using a Google spreadsheet to track servers and services running on them and which ports they were on so that we could get some sanity, and maintaining that was really not a very fun job. So orchestration tools exist for this purpose, right? And there are a lot of them to choose from. Honestly, one of them is bolded here because it's really hard to recommend anything other than Kubernetes these days, just honestly. There are potentially reasons for some of these others. Nomad from HashiCorp is a really nice, simple to use tool. It's not super feature rich, but you can get going with it in kind of an afternoon, really. If you're running DCOS in your data center, Mesos and Marathon actually probably make sense. If you're running in Amazon and you just want to get some experience running Docker and running Docker services, ECS is actually very easy to use and it can get you going. You really don't want to be running 90, 100, 200 services in ECS though. You just don't. It's kind of a unique beast, and you're not going to find a lot of tools, a lot of community, a lot of skills out there to manage that. So Kubernetes really is just the way to go, unless there's some particular reason not to. Observability is a big topic and super, super important. You've got all this stuff running out there. You need to understand what it's doing, what's working, what's not. Lots of questions. What services are healthy and which ones aren't? Which instances are healthy and which ones aren't? Someone's service is slow. Why is that? Some instances of their service are slow and others aren't. Why is that? Why are things sometimes timing out? Why are services spiking the CPU? And so on and so on and so on. You've got all these parts moving out there. Back in the monolith days, it was much, much easier. Not to oversimplify it, but essentially you've got a bunch of servers running the same code. You got a load balancer in front and a database behind it, and it's kind of working or not. You've got many, many more things to deal with when you start to split this up into microservices. So you reach for metrics, right? We can just start collecting lots and lots of metrics and understand what's going on. They multiply so quickly. Even with 20, 30, 40 services, you're going to start overloading the team with information. And you can't just flow metrics into something and expect to get answers out of it. You'd want to start with metrics on container, CPU, and memory utilization, right? And then the servers as well, so that you understand what's going on there. And then you've kind of got the disk and network usage for everything, and make sure that no service is choking out the others by hogging all of the networking. And then you want the request latency for all of these things, and you've got maybe 100 services, 10 instances each. Suddenly that's 1,000 services, all sending latency information in, and you're trying to understand what it's doing, and you see where this is going. It's just too much information to manage. So I like to say what do you really care about and why do you care about it? As an example, if you've got a service that is randomly spiking its CPU and you're seeing that come up in alerts and so forth, but your users are using your site and nobody's complaining and the top level user metrics are looking pretty good, do you actually care about these random CPU spikes? No, I would say you probably don't, and you certainly shouldn't be waking someone up at 3 a.m. because of it. So thinking about what actually matters is really, really important and when it's going to matter. All of this observability data comes in several categories. I think we all understand the importance of logs, metrics. Distributed tracing is actually super important that I wanted to call out here, whether it's Jaeger, Zipkin, Stackdriver Trace, and so forth. New Relic has now added distributed tracing to their product as well. Understanding the flow of calls between all of your services so that you can see what's fast and what's slow is insanely useful information. And then obviously the APMs as well. But you collect all of this information and you can see that if you're getting logs and you're getting metrics and you're getting distributed traces and everything else for 100 services times 10 instances each, that amount of data is very, very hard to make actionable, and you really need to think about what matters. So really the question is, who needs what kind of information about your system? When do they need it? And how can they get it? I'd love to say install this, and this, and you're good, but every system is realistically very, very different. Everyone's going to care about different things to make sure that their system overall is healthy. Very quickly, going through user experience, your developers. Super quickly, think about how do your developers do their work in a monolith world. You've got your laptop, you've got stuff installed on your laptop, you're doing your development with a monolith, it's kind of all there, it's relatively easy to manage. Now suddenly you divide this into many, many, many services, and it gets very complicated to manage. And in fact, it won't fit on a developer laptop anymore. Everybody always wants their development environment and their test environment and their production environment to be the same, right? It's like the ideal that we all reach for, because then you know that you're doing your development, you're doing your testing against the real thing, and when you actually deploy it, it's going to work. With a monolith, that's theoretically possible. It's still always more difficult than we think it might be, but it's really not realistic when you're talking about a microservices world. In our case, at Credit Karma, with 90 microservices, plus a database, plus all these other things, there's absolutely no chance that that's going to fit on a laptop, even now that Apple's given us more RAM in our MacBooks. So, you're running Docker in production. You want to run Docker on your Mac. Do you use Docker for Mac, or do you use a Vagrant box so that you know everyone's using the correct version, and then you've got the right base OS as well, so it's probably going to run the same way. And then if you're running Kubernetes in production, do you run Kubernetes on the laptop, and suddenly you've got like a dozen containers doing various things for Kubernetes using up space on the MacBook as well. Logging, metrics, you've got them set up for production. You need to set them up for development and test environments as well. Do you do that the same way? If you're running a service mesh and console, do you install that on your developer laptop, or do you just let them fend for themselves? The sad thing is that nobody I've talked to has solved this to their satisfaction. I've talked to a lot of companies. If anyone out there feels like you've done it and it's working for you, I would really, really love to hear about it. Everybody tries various different things, from running a bunch of service instances in the cloud and sharing them among the developers, to mock services for the ones that you don't really care about. So if I'm building a service and I care about 2 of them, I'm running those, and I've got mocks for everything else. Then you're maintaining all these mocks that are never really quite right and not simulating production data anyway. Or figuring out some framework for loading only the services that I care about based on what I'm developing on. It's very complicated, and we've gotten things working at Credit Karma so that we can kind of manage it, but it's a little bit manual and it's really not very perfect. We're still working on it. So, to sum up, working our way through all of these questions, the main takeaway is that when you think about running microservices, you're kind of thinking about running some Docker in production. You got some services going, they're talking to each other, and it's really easy to minimize the impact on every part of your world, from developers doing their work. I didn't even talk about the impact on CI/CD pipelines. We put a lot of work into that, the security aspects of what's in these Docker containers, all the way out to test environments, production, and everything else. It's a lot of impact that's kind of easy to not see when you're first getting into it, but it's really, really worth it once you get there. We got into this because we wanted our developers to be more efficient and happier, and giving them their own services that they can own, that they can iterate on at their own speed, and be independent from everyone else has been totally worth it, but it's definitely been a long road. Thank you very much.
All
right.
So if I've got like the microservices and they're behind load balancers and things seem to kind of be working okay, why would I need to add a service mesh?
Well, it definitely depends on where you think you're going with your microservices world. So the question is why would a service mesh be worthwhile? So if you've got things going pretty well just behind a load balancer, then you're probably not running dozens of services. And as your developers start to expand and your services start to expand, then you're going to want to make more efficient use of your resources and free up the mechanism by which you're putting the services out there. If you've got, let's say 5 to 10 services and a bunch of instances of them each behind a load balancer, then that kind of means you've got all of the instances of that service listening on the same port, but on different servers, which is actually how we started out. And that makes it really, really hard to make efficient use of your server resources. And you've got the load balancer pointing to these servers. Is that load balancer dynamically configured? If you want to add more of them, are you going to use Terraform, provision up some more instances, deploy your service to them, and make sure that each one is there, and then add those to the load balancer? And it can work for a while, but the service mesh really provides a ton of additional flexibility and information. In the case of using a load balancer, you're relying on the load balancer health checks to tell you what's healthy, and those are typically a little bit limited and hard to introspect. To know which of your service instances are healthy across your entire fleet of services would actually mean that you're inquiring of every load balancer, tell me what's going on, tell me what's healthy, which is a tough observability question as well. So it's definitely a perfectly good way to get started, but I think that there's a tipping point at which you've got so much going on that you're going to want to go past that. Anyone else?
Back to the architectures of the microservices, you said like for the read-writes on circuit breakers, you were doing that. Is there any libraries or third-party library which you would recommend to us, so that we don't have to do it ourselves, we can view of the burden to someone?
Right, so the question is the logic for handling like timeouts, retries, and so forth. Are there libraries to do that? There are actually. The main one, the only one that I know off the top of my head I can point to is a library called Finagle, which came out of Twitter. Finagle, Finagle. And Finagle is actually the library that the Linkerd service mesh was built on top of. So they were happy enough with it, and it provides both the management of timeouts, retries, and so forth, as well as emitting observability data, which is obviously super handy. So when they started Linkerd, they built on top of that to kind of get all that for free. We've been using Finagle at Credit Karma for our Scala services as we figured out the service mesh world. We found that the service mesh still makes it easier to handle multiple languages and so forth. Finagle is a Java library. So if you suddenly start doing services in Node, start over. And so that gets tough. Again, you're maintaining all of this for all these different languages. Very happy to talk afterwards. Thank you.